Hi, it's Zarek Daniel, and today actually I was about to put a video about this subject 3 days ago, but I do see if a person like me who really wants to put something new. The new thing is, of course, college is good. I mean, beautiful. There is nothing better than college. Today is 20th of 2016. It is Friday. Then the subject of the video today, I'm gonna go over the video. Actually, the reference is this book, the Dennis G. Zeal. I'll go after that, the author. The title of the as you see, the thing that I'm writing, so see, when you say this differential equation first course, then is Zeal. First of all, it's kind of here, as you see, the written things. The way that I see here is just the regular, or any when I'm just circling this, everything is regular, right? Even if I do show the book, I think the inside things will be reverse. See, everything is kind of upside down, and even if I put the book here, it's not gonna fit, right? If you keep this book here, maybe here, you can feel the differential equation in some way from the other side, but if I do turn the book this way, it's totally different. So this third reference, it's the best book in differential equation, and I'm not that dude who just, I don't want to show off because I liked it, but at least I'm in middle of, not a middle, let's say when a MIT person talks, he says, even this first course, it doesn't mean that you are kind of, it's a little bit you need to, because the last video I'm talking about this Illuminati and everything, I think with the concept of differential equation, it's better understanding. The other thing I'm saying, it's all about that antimatter and the feeling, the purity, the honesty, because I'm not there for entertain myself. This is not something to entertain you. This is something that, I'm gonna put this Laplace transform because it has something that it's really, for me, was great. It says, I'm gonna go over, derivatives of transforms. Of course, I'm sure if you want to talk about this subject in college, you need to have at least master degree or doctor. But here I am, this is on YouTube. And if I'm saying crap, don't watch it. I mean, this is my channel and I'm talking about the subject. To be honest, it is college level, right? But, the other thing is, this is kind of when the USA math comes in, because this is my, when the USA math comes in. USA math idea is this. It's, to be honest, I need to, maybe, genius, I think it's doing something different, something creative, something new. Maybe I am genius because I'm doing these things. It's not complicated thing, but at least it's something new. And after me, I mean, then becomes the level of the defined geniusness. Because I am not crazy. You know, because crazy or I am not using anything else but brain and heart and soul. Soul is here. Soul is some energy that you have, and everybody sees it actually. Some people, they don't want to see it. It's their problem. So let's get to the subject. At least I'm showing without a degree, without anything I can explain, because if the interchange of differentiation of d of f of x over dx, this is interchange of differentiation, and integration, interchange of this and this, interchange between again, the beautiful thing about these things are interchange between this is possible. We can go and prove the derivatives of transforms. And of course, in the first page I put this one, so I'm going over derivative of transforms. The other thing, the beautiful thing is I'm not getting any dirty. This is so clean. You watch the video and you just see. I don't want to entertain. I don't want to. And kind of the point is mathematics and all the things that I'm putting in. So here, the Laplace transform of f of t is equal f of s. When we differentiate it, so d of Laplace transform of f of t over, again, I'm watching it because, again, when you differentiate this, the beautiful part is, you differentiate, I think the whole thing, ds, is equal the differentiation of f of s ds. It's the same thing. You differentiate it based on this. So the differentiation of that, we know what is the Laplace transform. We know what is the definition of this one. It is 0 to infinity e of minus st f of t dt. That's why you have t here, but here appears s. So when we differentiate this, d of this, so differentiation of this is this. So exactly, everything goes here, and exactly we end up here. So exactly, beautiful. Exactly, I'm doing it very beautiful, because in the book is kind of, it's not putting this part. Actually, this part is hidden. The way that I'm explaining is much better than book. I mean, it's the same thing. I'm watching the book, but it's different. So you differentiate that one, so you write it, right? D of integral of exactly e minus st f of t over d of s, because I'm substituting that one, over d of t. So because again, the interchange here, it comes the beautiful part. that the interchange. Here was the interchange between these two. Here it comes. Here is the most beautiful part that happens. You partially differentiate the inside. Partially differentiated e minus st f of t differentiation based on s dt. So, wow, so beautiful. 0 to infinity, and it's the same. We don't need it. So here we write this one, and as you see, you know, I wrote it there. I'm not watching the book, so I know what am I doing. So trust me. Follow my lead with this part. So, as I said, you know, there was, right, the differentiation of f of t over d of s equals that thing, you know, let's go here. The partial differentiation of minus me of s of t, f of t over partial differential of f of s is equal, it's going to be minus s e minus st over, you differentiate. It's just over. The other thing is because not minus s, minus t. This was tricky because you differentiate based on s, so the t comes out. Minus t. Let's correct myself. Minus t. So we differentiated 0 to infinity d of t. So that thing, that outside thing goes inside. So right now, it's the same thing, f of t, because it was f of s, so this one as a number, this become as a number, doesn't have, nothing gonna happen. So this one will be equal t minus t e minus st f of t dt. So here it is. Here we find a formula. It's going to be minus t, same thing, Laplace transform of f of t. So this gives us a formula. I mean, this minus, exactly, minus Laplace derivative of this is equal this. Wow, it's so beautiful. So the Laplace transform of t, f of t, is equal minus differentiation of Laplace transform of t over ds. So this gives us formula that Laplace transform of t to the power of n f of t is equal minus d to the power of n Laplace transform of t over ds2. Again, I'm going to write it over because if you just go back and just see what I did, it's so beautiful. This was kind of differential DE kind of subject of kind of beautiful because you know, when you have this partial differentiation, it goes, imagine me next year and the year after, how my brain works, because I said, you know, I put some chess thing, I put some math thing that I'm already putting, chess I put, math put, and coding as well will be. So today was so beautiful day about math that I show the interchange, you know, the way that I'm talking, you know, the way I'm thinking. Of course, again, I'm saying, you know, so beautiful. It was so beautiful. I never be tired of watching, doing this because I show you what it means. Laplace transform of f of t is equal minus differentiation of Laplace transform of no, differentiation of, yeah, Laplace transform of the f of t to the power of n ds to the power of n. It's beautiful. It's beautiful. Or you know, the other thing, the beautiful part was, you know, the kind of simple part. Instead of that, you put f of s, because it's going to be kind of nice, good looking. I mean, that's what's kind of that nice looking way of. Because I hate to memorize things, you know, minus, because that minus differentiation of n d of s to the power of n. Why we are writing this one? Because here you're not seeing this s here, you know, you're kind of, what is s, you know? So it's beautiful, beautiful, beautiful application. And yesterday I was discussing discrete math, discrete math, because see, the k here goes discrete math. And the beautiful part was when you have you know, the one that I solved was, you know, was kind of point like this. It's kind of an address. It's this one, and then yeah, I will go work. When you have something like this, these are possibility of roads, you know. It's all graph theory, and you know, for A, B, C, D, E, F, G. I mean, how the Uber works, I mean, it's so beautiful. For example, let's say this is 3 mile, this is 4 mile, this is 7 mile, this is 8 mile, this is 10 mile, this is 7 mile, this is 5 mile, this is 6 mile. You start to put, you know, it's so beautiful the way that different algorithm, different things, you know. You have this iteration here. You have the vertex. Then you have weight. You have edge. So you start from something A. You choose A. You choose the first one, iteration is A. You choose A. Then from A, which one is shorter? 3 is shorter. So you choose B. Weight is 3. And then this is going to be 0, 1. Then it is 3. Then you choose, you say AB. Then from AB, you choose, so you travel here. And then from here is 10, 8. So which one is less? This 8 is less. So you go here. So you choose E, the weight is 8 in the second, and then it is B to E. Then this is second one, and we travel here. We cannot go back, because if we go back, it's, oh, we didn't cover actually this D. We didn't cover the D. So 3. 3. Because I want to touch that thing. If I start from here. The other thing is, you know, because you want to go to, eventually you don't want to miss this D. So maybe I should erase this. Ugh! Is it possible to go back? Oh. Maybe in the next video I will explain, or how many minutes? Next video I will explain that one. Next USA Math. Here I erased it. And yeah, I don't have time to go even for that one for this book. So at the end I would say Chess, math, and coding are fun. First, but then money, Bible, abstinence, and happiness. First of all, we do have this physicality. I mean, our physicality is the point. So I think the physicality, the best. I mean, any level of these things. Any level of these things. If you have them in your life, then you read the Bible, you make your money. It's a choice. You have your good life, pure, clean life. Live in peace. Bye.